Hi there, Daryl Wittenberg here with Industrial Solutions and Innovation, and today we're really excited to show you a video of our newest in the Redi2Weld or R2W line. This is our R2W-3 Combo, and the combo really means that we have both MIG and TIG capability on the same system. Today, I am not going to be running the welder because I'm a salesman, but I've got Reagan here who actually designed a lot of this behind us. Reagan's going to be doing the operation from our operator control cabinet, and he's going to be able to run this entire weld on the operator control cabinet using the Xyrus vision system we have employed. So Reagan, if you'll step on back there. Today we're going to weld for you a 6-inch Schedule 10 from root to cap, and then we're going to pivot this column and boom over, and we're going to weld an 8-inch Schedule 40 carbon steel. The 6-inch Schedule 10 is stainless, so we're going to run a hot wire TIG root and then a cap, and the system will automatically do that weld from root to cap without stopping. When we do the MIG process, we're going to be using a modified short circuit on the root, so we'll actually stop after that, inspect the root, and then we'll do a fill and cap using that system on the adjacent headstock. So that gives us the ability, if you're in a real world situation, of being welding on one line while you're fitting up and loading on the other. On this we have our cart system that is actually mechanized. We can drive it up and down the length of the track, and this track happens to be 25 feet long. We can go up to 45 or 60 feet depending on what your application may need. These headstocks actually have the ability to turn a 36-inch long radius elbow with the flange welded to the elbow. So we have a lot of flexibility on the center line adjustment of the headstock. That actually adjusts up and down with a mechanized drive, and then we pin into location for safety. The column and boom rotates around. It pins into location for safety as well. We have an EWM Phoenix 552 power supply running our MIG welding. That gives us up to 550 amps of 100% duty cycle on that power supply. Next to it we have a Tetrix from EWM. It's a 352 with hot wire TIG capacity. That gives us up to 350 amps of hot wire TIG welding capability at 100% duty cycle. We have an onboard water cooler for the Xyrus camera system. So we can weld with this system at 100% duty cycle and never overheat the camera or the torch. With this system, we can literally get into deposition rates that would rival sub-arc. On our TIG side, we can get into deposition rates that would rival MIG. The advantage that that gives you is a very high level of deposition on the weld and a very high efficiency rate. We can be in that 75 to 90% efficiency with our arc time. We have a lot of options on the control side of this as well. This is our attached remote that is tied to the column and boom. With this, I can steer everything. So I have AVC, which is the arc length control attached here. I have steering right to left for our horizontal or our oscillation. I can rotate the part. I can adjust wire feed speeds and things of that sort while I'm welding using this remote. Reagan, from his view, can also control everything over there. So I'm going to step around to where Reagan is. And from his view, this is what he's going to see as an operator. So he has all the controls right here on this HMI, and it allows him to control everything in the process from here without having to stand over the arc. This really allows your operator to be safe and also reach those really high levels of efficiency that we're looking for. Coming back around to the front of the machine, One of the really neat features that we've added to this process is on our MIG power supply, we can have one gas that we would do the route, say 75-25, and then we can have it programmed to switch to another gas for our fill and cap passes, so we can be in that spray mode. So it really gives you that flexibility according to your WPS to stay within those bounds. On the hot wire TIG side, it's an awesome fact that we can do this weld with a really low heat input. Our system will actually be calculating the heat input while we're welding, so we'll be able to get a readout of that, but normally on a 6-inch schedule 10, we're going to be somewhere in that 15 kilojoule range. So we have a lot of flexibility, a lot of adaptability built into this system to allow you to get the most out of it. So that's a general overview of the system. One other thing I wanted to mention is we actually have our boom. It is actuated on a rack and pinion here, so we can drive that in and out as we need to meet that center line of the weld. I'm going to grab my hood, and I'll be standing over the weld here, kind of discussing what's going on. We'll be switching camera angles periodically during the weld so that you can see what's happening. But Reagan, when you're ready, we can strike the arc. So we have a period of time built into this for that puddle to establish, and then our wire feed starts automatically. Now we're actually doing hot wire TIG, so we're oscillating the wire as it hits the puddle. We're inducing a vibration on the wire, which gives us the ability to flatten out that puddle. That popping noise that you hear there, that's actually the short circuit of the hot wire. That's something I want to hear while this thing's welding. Now we've put a window in this so I can actually see that I'm getting good penetration on my root pass, so I've got good reinforcement on the inside. The way that we fit this up is we do a square cut with something like an Axe-Air saw that gives us a really square cut, and then we move to a tack square to the bevel of the fitting. We don't bevel the pipe. We also don't do an open root, which allows us to really maintain our purge gas on the ID. I'm going to step around to the other side where Reagan is, and we'll take a look at what the operator would see. So Reagan is steering based off what he's seeing here in the column, on the camera. So as you can see here, he can see the puddle. He's got a crosshairs there that he's using to align himself, and he's just keeping this thing in the center of that joint. Right now it tells us that our kilojoules, we're running at about 15, 16 kilojoules on this root pass. So we're still welding nice and cool, and if you look up here at the power supply, it's showing that we're in a pulse mode, and it's allowing us to weld without having to worry about the managing of that pulse. It's telling us that we're pulsing between about 165, 170 down to 90. Step back around here to the weld. Nice penetration on the inside. We're about halfway done with this root pass. Now then, if I wanted to steer this with this, I could. I could drive everything from here. So as your operator gets more comfortable with the system, you can simply go from running right on top of the arc to running like Reagan is right now from the remote area using the camera. Getting real consistent fill on the inside, a nice consistent root profile. We have nice color because we've got a good purge. Everything's going the way we want it to. Stepping back around here to where Reagan is, I'm going to switch the screen a little bit and look at the program. And on the program side, we're running 65 inches a minute of wire, and we're only putting 40 amps of hot wire current on this. So we're not really overdoing the heat on the hot wire either. And in this screen, Reagan could change anything that he wanted to change. We have our travel speed set at 3.75 inches a minute. If he wanted to change that, he could. I go back into the operation, and now this is where he would spend most of his time while the arc is happening. It's telling us down here what percentage of completion we're at right now. And on this percentage of completion, we're about 40%. Now it's a 2-pass weld. So at 40%, we're about to come into that tie-in. I'll step back around there when we get ready for that tie-in. That tie-in portion's coming up here pretty soon. When it ties in, it will automatically start oscillating once it does the tie-in. Now we have a couple of ramping features built into our tie-in that allows us to make sure that we're not overdoing it on that tie-in. Did you notice there that tie-in started? It automatically started the oscillation process, and now we're in that cap pass. Stepping back here to where Reagan is. He's making a couple of adjustments. And you can see from the profile that we're getting out of the vision system here that we're getting a nice cap pass there that's very consistent. Because this is a Schedule 10 weld, stepping back around here to where the arc is, we don't need a lot of energy and we don't need a lot of wire. We can honestly get 6-inch Schedule 10 on down in one pass, but most of our clients find that their client would prefer that they have a rude and a hot and then a cap pass. So we can do it in 2 passes, but if your client will allow or your application will allow for a single bead pass, we can get this in just 1 pass. So we have our cap pass programmed in at 3 inches a minute. Again, if you wanted to adjust those numbers, we can adjust that on the fly. But what we find is these are very forgiving numbers. They give us a consistent quality. And as you can see there on the camera, we're getting a really nice bead profile on that cap pass. This is coming in at between 16 and 17 kilojoules on the cap pass as well. So again, on the entire weld process, we're welding nice and cool. We're not cooking our stainless. We're not making this something that we'd have to worry about interpass temperature either. Everything's nice and controlled. Stepping back around here to where the arc is, just a second. Reagan, what percentage are we done? We're about 2/3 done with this weld now. And our root looks nice on the inside. Good color. And I can tell by looking at the root here, we're not reconsuming it. So our cap pass is going on the way we want. And we've got about a third of the weld left. Now, when I say a third, keep in mind it's a 2-pass weld, so it's not a third of a pass. We've actually only got about a 1/6 of a pass left. So when we do our tie-in here, one of the things that we've also designed is we've designed a nice downslope feature into this, so it allows us to downslope the power and then pull the wire out and give a nice feathered edge to that trail off, so we don't have to worry about shutting the arc off really early. It'll give us a nice downslope, obviously meeting the criteria that you would need on any weld that you're presenting. So our wire is now stopped and we're into that downslope mode. And there we go. Weld is finished. And what we'll do now is we'll just kind of we'll raise up the torch a little bit and rotate that underneath us so you can see through the arc view. We have a really consistent cap pass. On the ID, unfortunately, you'll have to take my word for it on this because we don't have a camera inside the pipe. We have a nice consistent root penetration. We don't have a lot of color there. The purge really works well by being able to put those two pieces together without an open root. Okay, so now I'm going to show you one of the most impressive features of this system. We're going to, Reagan, if you would, jog the torch up a little bit. We're going to pivot this around now. I simply pull this pin and I can rotate my column. One of the features we've built into this system is a system that allows us to change from MIG to TIG very quickly. If you'll notice this right here, this is our torch holder, and it mates to a torch holder just like this one. This is held in with precision dowel pins and magnets. So all I'm going to have to do to change over from MIG to TIG, I'm going to pull the TIG torch off, slap this one into place, and I'm ready to go. I put my camera back on and we're ready to weld. It only takes about 2 or 3 minutes to go from a TIG process to a MIG process. I took the camera off of its mount. This mount is held in with a magnet and 4 locating pins. Reagan, if you don't mind coming over here and being my extra set of hands. So I'll let him hold the camera. I simply pull the MIG torch off of its base and then put the TIG torch into the holder, just like that. Then I take the MIG torch, route my cable around, slide it into place, and now I can put my camera back in. And we're ready to weld. That is how easy it is to go from MIG to TIG using the Redi2Weld-3 Combo system. Okay, so now we're set up for our MIG weld. We've shown you how to change the torch out. So now we're ready to go into this MIG weld. It's essentially an 8-inch Schedule 40 weld. We've cut these using our Watts-Muller 364 pipe profiler. So we've cut these using plasma. We've dressed the end, cleaned them up, flapper wheeled them, and we're ready to weld on this. We've left ourselves an 1/8-inch root opening. Tried to make this as real world as it can get. So what we've got is we've got our MIG torch in position. We've feathered out our tacks. We're going to put in a root pass using 75-25 gas. And then when we go to our fill and cap pass, we'll actually go to a 90-10 so we can be in a spray mode. So Reagan, if you're ready to go, I'm ready to go. I think we're ready to weld. We actually put in a current value to give us an arc length. We use that because we know the pipe's not round, we know the fittings aren't round. And this allows us to automatically adjust for our root opening, widening. It also allows us to work through that ovality that's going to be natural with any pipe or fitting that we're going to be welding on. What we're able to do on the fly is we can adjust our oscillation width, speed, and we can also adjust our dwell time, both on the right and left, and also what we would call our excursion or our time in between. So by adjusting those things, when that root opening widens and narrows, it allows us to keep welding. Our operator doesn't have to adjust anything else. Sometimes the operator might adjust the travel speed if that root opening does vary more than what we would recommend. Our goal is that you have an 1/8-inch root opening and that we are plus or minus a 32nd either way. So that gives us a 3/32 on a minimum up to a 3/16 on the maximum. So I'll step around here where Reagan is and we can get a look at what he's doing. So off of the camera, Reagan can see exactly how we're penetrating. You can see here that we're actually getting good penetration on that ID, and he's simply monitoring that. We're getting ready to walk into attack. Reagan just took a drink of coffee. How many times while you're welding a piece of pipe can you take a drink of coffee while you're doing that root pass? So we're getting ready to walk into attack here, and what we will do, we'll actually consume that, and you'll see it taking place here on the screen. He's narrowing that oscillation a little bit as it comes in. We want our tacks to be about 1 inch long, and we're going to put a ramp on either end of it. You'll see right here as it starts to reconsume right there at the edge where that tack is completely reconsumed. And there you see that happening. It widens up a little bit coming off the tack, which is kind of normal, and he adjusted his oscillation. One of the other things you can notice is that arc is really soft if you can hear it in the background. That's because we're using the EWM Phoenix, which uses a root arc waveform. It's called root arc, and it's a modified short circuit. It's very forgiving. It also allows us to put these root passes in without a lot of adjustment because of the varying of the opening there at the root. I'm going to step back around here where the arc's going. As we look on the inside, we've got really consistent penetration here. We've got a nice root bead profile on the ID. Again, as an operator, if I wanted to, instead of being where Reagan is, I could actually run it from here. So I have all the controls that I would need right here in this pendant or where Reagan is sitting. I'm going to step back around where Reagan is. Coming off another tack here. You can see it widens up, so his oscillation width is widening a little. And it walks right through it. And you can visibly see that penetration to the ID. We're not too proud, but we are getting nice penetration. We're consuming the edge of that bevel. On our root pass, we're running at about 3 to 3.5 inches a minute. That's a very forgiving speed. Obviously, when we go to our fill and cap passes, we're going to step that travel speed up quite a bit and we'll dramatically increase our wire feed. We'll actually be in a pulse spray mode when we go to our hot fill pass on the next pass. And again, what we will be doing is we'll be changing from this 75-25 gas that we have running now for the root. We'll be actually switching over to a 90-10. What he's really managing here is he's making sure that that oscillation width, that he's spending an equal amount of time on each sidewall. Now, a lot of clients ask us, can we run 035 on the root? You could, but because most clients don't want to have to change wire after the root pass, we're actually going to run our 045 on the root pass, and then we'll fill and cap with that same wire. About to walk into another tack. Reconsuming that tack, as you'll be able to see here in just a minute as you come on the edge of it. That puddle will start to become visible on the ID. There we go. Reconsume that entire tack and we're back into the open area. By and large, we're also welding substantially cooler. We're running right now at about 26 kilojoules. Compare that to a manual weld. We're going to be a little bit cooler than what you'd normally see on a manual weld. We're also going to be much more consistent on speed than what you'd see on a manual weld. It's conceivable that when running this system, you could have that target of hitting 200 diameter inches a day with a system like this. The real issue there is keeping enough pipe in front of it because it will typically weld through those spools faster than you would manually. Many of our clients are going to see somewhere between 300 and 400% increase in weld output in a day once an operator becomes comfortable with the system and is comfortable with how to adjust the oscillation on this root pass and make the adjustments needed in the welding process. That typically takes about anywhere from 60 to 90 days, and they're running at full potential. And the install and training on this is actually pretty quick. It takes about a week to install and train on this system. And we will be having them operating at full potential by the end of that first week. But they won't be running at full speed, obviously, because there is still a learning curve. So anywhere from 30 to 60, maybe even as long as 90 days, is how long it takes to get over that learning curve. So we're coming into where we started our weld, and you're going to see us do a down slope, and it'll tie in. There's our tie-in. It downslopes, and we're ready to go now to the next pass. Now, if we were doing a traditional production weld, we would actually recommend that you step in and clean the toe of this weld using a wire brush or a grinder with a wire wheel on it. But because we're doing this for demonstration purposes, we're actually just going to go ahead and weld right over the top of this. There is no need, once we go from the root to the fill and then cap passes, you should be able to weld from that point on without stopping. So we're going to run a pulse spray mode for this fill pass. And then Reagan, are we doing a split bead cap? So we're going to do a single bead cap on top of this. If you wanted a split bead, we could do that. So Reagan, I think we're ready to go when you are. So as you can see from that arc view, we are adding a lot more material in this pass. We're running 045 wire. We're in a pulse spray mode. I'm going to step back around here to where Reagan is. You can see from the arc view, we're really getting a nice consistent bead. And you can see the bead or the arc profile very clearly through that Xyrus camera. Right now we are running an arc current of about 285, and we are giving it about 360 inches a minute of wire feed. Now if Reagan wanted to adjust things on the fly, he has full control right here. So he can adjust the wire feed, he can adjust the oscillation, the dwell time, he can adjust all of those oscillation widths, all of those things right here. So he can make this thing look the way he wants it to and tune that weld the way that he's looking. We can also build into this program some controls that allow you to limit operator interface to where you stay within those parameters in your WPS. It's in a Windows environment, so you can have an operator setting, a supervisor setting, and then an administrator setting. Right now we're traveling at 13 inches a minute. So we're going to get around this pipe pretty quick. I'm going to step back around there where the puddle is. And like I said, at 13 inches a minute, we're really going to rotate this thing around, and we're going to put this pass in pretty quick. We're on an 8-inch pipe, so we've got roughly 25, 26 inches of circumference, and at 13 inches a minute, that's going to put us at about 3 minutes on a pass, 2 to 3 minutes. We stepped into our cap pass, widen the oscillation, we're going to do a single bead cap. So now on this cap pass, we're running at about 11 inches per minute on the OD. We're still running in that 360, 380 inch per minute wire feed. Our current value is right at 300. So we're really putting the metal down on this. It's a 3-pass weld on 8-inch schedule 40. The first pass we're running about 3 inches a minute. So you figure that out. We're running at probably about an 8-minute to 9-minute root pass. We're running about 3 to 4 minutes per pass after that. So if you look at that total, figure 9 minutes on that root pass and then a total of 8 minutes on a fill and a cap. That's a pretty darn quick time. And so you can imagine if you have several joints to weld of this same type, you're going to get through those in a spool pretty quickly. This Xyrus camera really performs well. We're able to get a reading on the camera itself. We're only running at about 43 degrees Celsius. So even with that arc that close, we've got a chilled water cooler on it that's keeping it down where it needs to be from a heat perspective. We're coming up on about 90% of complete on this weld. So I'm going to step back around there where the arc is, and we can watch this thing tie in. So we're tying in here, and then you're going to see the system downslope and tail off. So Reagan's going to rotate that around so you can see how consistent that root pass to cap pass weld is. We've got a very consistent single bead cap here, very repeatable. So I hope by showing you this system where we were able to run in real time a stainless steel weld over here on 6-inch Schedule 10 and then transition over to an 8-inch Schedule 40 carbon steel weld, I hope that shows you the flexibility you gain from the Redi2Weld system from Industrial Solutions. Thank you for taking the time to watch this video today. And I want to stress to you the fact that at Industrial Solutions, Solutions is our middle name.